Hello and welcome to limits of difference quotients. So first up, just a quick review. What is a difference quotient? So the difference quotient for a function f at x, um, difference quotient for function f at x is we take f of x plus h minus f of x and divide by h. So it turns out this is simply the slope of the line. So this is the slope of the secant line between the points x, f of x, and x plus h, f of x plus h, on the graph of f. So on the graph, y equals f of x. So here h can vary. We can have 2 points very close together if h is small, or 2 points far away if h is large. So we often use this difference quotient and take its limit to try to figure out what line has a slope matching the curve exactly at a point. And so we will, in calculus, we study this, the limit of this difference quotient as h gets really small, as h goes to 0. So in this case, we're going to look at the function f of x equals x squared minus 4. And we are going to approximate the limit, the limit of the difference quotient of x equals 1 as h goes to 0. So again, we're looking at the limit as h goes to 0 of f of x plus h minus f of x over h. But here we are going to be using at x equals 1. So we will replace all those x's with 1. So we are studying the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. So from here we plug in. So we are looking at x squared minus 4. And we need to plug in both 1 plus h and 1. So we need f of 1 plus h. F says that we take our input and square it and then subtract 4. So we are looking at 1 plus h squared and minus 4. And then f of 1, we are looking at just 1 squared minus 4. So that 1 plus h squared becomes 1 squared, or 1, plus 2h plus h squared, then minus 4. And this becomes h squared plus 2h minus 3 if we rearrange it. And then 1 squared minus 4 is just -3. So now if we put these back in our difference quotient and our limit, we are looking at the limit as h goes to 0 of, in green, we have h squared plus 2h minus 3, and then we will subtract off our pink -3. Then on the bottom we have h. This becomes the limit as h goes to 0 of h squared plus 2h minus 3 plus 3 over h, or the limit as h goes to 0 of h squared plus 2h over h. So from here now, we're supposed to approximate this limit. So we have our various methods for approximating. We can graph the function and look at what happens, or we can just plug in values close to h equals 0 and see what happens that way. And we'll go ahead and just graph it. So switching over to Desmos. Back in Desmos, we now have over on the left, y equals h squared plus 2h over h. So here is our what we wanted to take the limit of, h squared plus 2h over h. And we want to take the limit as h goes to 0. So we're going to trace in along the graph, getting closer and closer to 0 from both sides. And as we get in close to 0, it looks like our function is approaching 2, or our difference quotient is approaching 2. So we have it appears our limit is going to 2. So here's that graph we had. Again, it looks like we are approaching, as h goes to 0, the y value is approaching 2. So we can say that our limit of our difference quotient is approximately 2. So as our 2 points on the function f get closer and closer and closer together, that slope of the secant line seems to be going to a slope of 2.